CCIEORDIE.COM. I'm Artec, and in this video we're going to have a little fun with VRFs. If you'll notice in the task list up here, R1's addressing is not done, which is part of the lab, and we'll get to that. R2, R3, and R4 are currently addressed. You'll notice also that R1 is going to have the same IP address for each individual interface, and R4, R2, and R3 are going to share all the same IP addresses, but they're going to have individual VRFs, and that's how we'll keep them separated, as well as using the route distinguishers and the route targets. So we're going to name a VRF for each host. Remember VRF forwarding for each interface. Without that, it's going to explode. We're going to create our unique OSPF process per router per VRF and configure the all zeros network for all OSPF processes. We're going to enable OSPF on each spoke, and then we're going to verify complete connectivity at the end. So let's get started. Config T IP VRF for host 2. The RD is going to be 200:2. Makes sense? Route target both 200:2. Good. IP VRF host 3. The route distinguisher is going to be 300:3. Keep it simple. Route target both 300:3. And then IP VRF host 4. The route distinguisher is going to be 400:4. And the route target both 400:4. That will preclude us from typing import and export both at the command line. You'll see in the running configuration that both the import and export will show up. Now for the interfaces, we don't want to forget them. Interface F0/0. IP VRF forwarding for host 2. And now we need to give it the IP address. IP address 192.168.1.1. 255.255.255.0. No shut. Now interface F1/0. IP VRF forwarding for host 3. And the IP address is going to be 192.168.1.1. 255.255.255.0. No shut. And now interface F2/0. IP VRF forwarding for host 4. The IP address is going to be 192.168.1.1. 55.255.255.0. No shut. Great. We're going to make an individual OSPF process for each one, and we're going to create an individual router ID as well. So router OSPF 2 router ID 0.0.0.2 network 0.0.0.0 0.0.0.0 area 0. And they're all going to be in the same area as well. Area 0. Router OSPF 3. Whoops, we made a mistake on the first router. Router, no router OSPF 2. We forgot to put it in the VRF. Router OSPF 2 for VRF host 2. It's not going to work without that. Router ID 0.0.0.2 and network 0.0.0.0 0.0.0.0 area 0. Router OSPF 3 for VRF host 3. Router ID 0.0.0.3 network 0.0.0.0, 0.0.0.0.0, area 0. Finally, router OSPF 4 VRF, host 4, which is the VRF name, router ID 0.0.0.4, network 0.0.0.0, 0.0.0.0, area 0. Great. Now spin up the routing processes on R2, R3, and R4. Config T router OSPF, and it doesn't matter what the process name is here. Router OSPF1 network 0.0.0.0, 0.0.0.0, area 0. And that process should be coming up shortly. Config T OSPF is a little slow. Router OSPF1 network 0.0.0.0, 0.0.0.0, area 0. That should be good on that. Config T router OSPF1 network 0.0.0.0, 0.0.0.0, area 0. Hey, we got some adjacencies. Do show IP route for VRF host 2. Hey, look, we see its loopback. Do ping VRF host 2 IP. Yeah, the syntax is a little funky. And that's good to go. Do show IP OSPF interface. This is a funky one here too. There's router ID 4, and there is 3. Where's 2? And there's 2. So let's do ping VRF host 4 IP 1.1.1.1. And there you have it. Do show IP route for VRF host 4. And there it is. Now if we look at the global routing table, do show IP route, we won't be surprised to find that there is nothing. So that's a little VRF fun, and it was fast and furious, but I enjoyed it. I hope you did too, and see you next time on CCIEORDIE.COM.